Okay, students of class 10, today we will learn how to solve numerical problems in mirror. But especially today we are going to learn about magnification. What is magnification? And what is the importance of magnification? What are the formulas involved in magnification? Especially in case of mirror we are talking. Before the term magnification, to understand, just see what is written on the board. How to solve numerical problems in mirror. Actually, when we want to solve numerical problems in mirror, then we have to keep 2 or 3 things in our view. First, mirror formula. Mirror formula is very important. 1 by b plus 1 by u is equal to 1 by f, where b is image distance, u is object distance, and f is focal length. This formula we will use it. Object distance means from the pole where the object is kept, that is known as object distance. Image distance b means from pole where the image is located, that distance. Both from the pole, principal axis distance we will measure, and focal length, that is also the distance of focus point from the pole, that is focal length. And sign convention, we have to put proper sign convention. Like in concave mirror case, you see this is concave mirror, focal length is negative. In convex mirror, the focal length will be positive. Similarly, about object distance and image distance, we have to apply sign convention. Second formula also we have to use sometimes. F is equal to R by 2. This is also very important formula. R is radius of curvature and F is focal length. So this is also important formula we have to use in our mirror problems, mirror numerical problem. Lastly, what I am going to discuss in detail is about magnification. That very important magnification formula we have to use and we have to apply. So first of all, we will learn what is magnification and what are the formulas of magnification. So magnification actually is a general term that is used for any optical instrument. Magnification is a general term that is used for any optical instrument. Magnification, its symbol is actually small m, sometimes capital M also. So magnification is a general term. What its mean? Its meaning is magnification is a ratio of image size to object size. Image size to object size. That means magnification M is generally HI. HI means size of image. HO means size of object. This is a general term that we use in case of mirror or lens or for any optical instrument. One more definition I will give you about magnification, that is more basic. Okay, magnification, in that case, a general definition that could be used for any optical instrument. Okay, so what is magnification? Magnification is a ratio of the angle made by image to the angle made by object when both are kept at least distance of distinct vision or at the same distance. At the same distance from eye. Okay, this angle are made on the eye. Okay, the eye. So generally, this is a very general definition, beta by alpha, where beta is angle made by image and where alpha is angle made by object. These general terms we have to use in higher classes also. Is good. For us, this HI by HO will be important. So let us go through details in case of mirror. In case of mirror, there is one more formula. The formula is M is equal to minus V by U. So from where this formula comes is minus V by U. How we can derive this formula from this to this? That I will explain. Okay. So see, I will make a diagram, and in the diagram it will be more clear that why for mirror it is M is equal to minus V by U, and from where HI by HO, why it comes minus V by U. Let us take concave mirror. Now see, this is pole of the mirror, midpoint, and maybe here center of curvature, and midpoint of C and P is focus point. So overall we are getting all this. We know this. Now what we are going to prove is from magnification HI by HO we will prove minus B by U. So let us consider an object. AB is the object and two light rays we will consider. First light ray that will pass from pole angle of incidence here I will be equal to angle of reflection. So light ray will be like this. Other light ray, or we can take from center of curvature, and it will pass again through center of curvature. And both light rays meet at a point where we get image. A dash, B dash. So here what we see, we will take two triangles, A, B, P and A dash, B dash. You see, in this we will take two triangles, A, B, P and A dash, B dash, P. Okay. Okay, what we see in these two triangles, that this vertical here, this is 90 degree, and for this also it is 90. Angle I is equal to angle R. This is general laws of reflection. That means ABP and A dash B dash P are similar triangles. Okay, this is इसका पानी गर्म हो गया है, नाला दीजिए. So here what we see, these two triangles if similar, then we can write similar triangles corresponding sides are in same ratio. Okay, if this thing you have learned in class 10, it's okay, otherwise you are going to learn. That is the concept. Two similar triangles have their corresponding sides in the same ratio. Okay, so when we are talking about corresponding sides, then AB divided by A dash B dash is equal to PB base divided by PB dash base. So we are taking these two triangles. So it is, what we are going to prove? We are going to prove that magnification for mirror is minus V by U. HI by HO is a general formula, and this also is a special formula for mirror. For that we are doing all this sort of things. So now, using appropriate sign convention, we know that AB is object size HO, and HO is always taken positive, so plus HO. A dash B dash is real and inverted image. Below the principal axis, we take it negative, and this is image size, so minus HN. We are putting proper sign convention. PV is object distance. You know, from the pole, this is object distance. In front of the mirror, the distance are negative. So PV will be object distance minus U. Minus U. Object distance is always negative. And then what is PV dash? PV dash, location of image. So image distance, but it is real image. In front of the mirror distance, negative. So minus V. So using proper sign convention, we are writing from here, we are writing this. So it is clear. Actually we are going to derive this formula for mirror, MSL to minus V. So when we are doing this, then minus minus cancel, and just we can reverse this. So minus HI by HO plus V by U. You can see here, minus we can bring this side, minus we can bring this side. So for that matter, we will get HI by HO minus V by U. So here HI by HO is actually M. So we are getting a formula for magnification in case of mirror, spherical mirror, plate mirror, or any mirror. And we have got M is equal to minus V by U derived. We are using here the diagram and proper sign convention. Okay. So these things are quite relevant and we should take care, because when we are getting how the formulas are derived, we learn how we are using mathematics in physics. These things, whatever you are learning in mathematics, we are using in physics. So these are the steps of learning. So I hope that you have understood this. Then second point, what we should know, that magnification for real image, it is always negative. Why? Magnification for virtual image, it is always positive. Why it is there? And also one thing, that in concave mirror we can get magnification that could be negative as well as positive. Why? Because concave mirror produces real image in 5 cases and virtual image in 1 case. So the sign convention in case of magnification, and that is also very important, we should understand. Sign convention in case of magnification. How we will use sign convention in case of magnification. Sign convention in case of magnification, that means what? For real image, let's see, let us decide what will be sign convention for real image. So we are using actually our formula, a general formula, this formula, hi by ho is equal to minus b by u. Okay, or we can use m is equal to minus b by u. This formula also we can use. So for that matter, m is equal to minus b by u. But for real image, we know that v is negative, u is also negative. So if we are putting here in a general formula, then let's see what it is coming out. Minus is already there, then v becomes minus, u also negative. So what we see, minus minus cancel, so magnification is coming negative. So for real image, magnification always negative. That is our conclusion. So whenever we are talking about real image, we should consider that the sign of m will be minus. This is a very important point. Whenever you see the sign of minus, m is minus, you can see the real image. Convex mirror don't produces real image. Plane mirror don't produces real image. So if I am asking question, there is a mirror which produces magnification negative. So it could not be convex mirror. It could not be plane mirror. It could be only possible with concave mirror. Because in 5 cases, concave mirror image, you have got, there are 6 cases actually. Only 1 case is for virtual image. 5 cases, real image. So if magnification is negative, that means concave mirror only can produce negative magnification or real image. Now talk about virtual image. What will you sign convention for virtual image? For virtual image, the sign convention will be very simple. Okay, and it will be again, we can decide like this: m is equal to minus b by u. This is our formula. We can decide from here, or we can decide from this formula also. M is equal to hi by hi. We know that for virtual image, always erect image. That means above the principal axis. So above the principal axis, we have to take hi positive for erect image. For hi upside, above the principal axis, and ho is always kept above the principal axis. This is also positive. So positive, positive. So magnification will be positive for real virtual image. So that the conclusion of our topic comes here. Magnification sign: real image negative, virtual image positive. So remember, these are very important steps to solve numerical problem. That our target is to solve numerical problem, and we should keep in the mind how to solve numerical problem. Okay students, thank you.